All right, so let's take a look at this example. We have r equals 6 divided by the quantity 1 plus 2 cosine theta. Now, before we kind of jump into everything, I want to pay attention to the fact that we have cosine, so that means that our directrix, the line that we're looking at, is going to be perpendicular to the polar axis, and it's going to be shifted. It seems like it's going to be 2 units, but again, let's make sure we compare it to the form. So the form is supposed to be EP over 1 plus E cosine theta. And the really important part here is to make sure that you have a 1 at the beginning of the form. If it's not a 1, then you're going to have to do some manipulating. But we should be able to clearly see that E equals 2. And since that value is greater than 1, this indicates that we are dealing with a hyperbola. And EP matches up with 6. So if EP is 6 and E is 2, that means that my p-value equals 3. So we're talking about that directrix being shifted 3 units, in this case to the right, because that's a plus, of the of the origin. Now, with hyperbolas, your transverse axis is going to be perpendicular to your directrix. So your directrix is not going to be the guy that's going through your 2 foci, right? So let's start plotting this and try to get an idea about what's going on. So I got the graphing grid right here, so let's see what we can do. So we're going to be shifting 3 units to the right. So I'm just kind of draw something here. All right, so the way that these are set up is that this origin has to be one of your foci. Now, if you're talking about a parabola, it's going to be the focus. But here we're talking about a hyperbola, which means that it's going to be one of the 2 foci. So that directrix is going to be 3 units over here to the right. So this is my D. Now, I need to get some key values here. So we talked about how the directrix is going to be perpendicular to your transverse axis. So it means my transverse axis, the one that goes through my center and goes through my 2 foci, will be what is for us here the x-axis. So it's going to be that guy right there. So let's see if we can get some points and start doing some mirroring exercises here and see what we can come up with. All right, so first of all, I would say start plotting some points here. So I want to find the r when theta is, let's say, 0. So if I plug 0 in right there, cosine of 0 is 1. So all of this would give me 6 over 1 plus 2, 6 over 3 gives me 2. So I know that when I have a theta value of 0, I would have an r value of 2. So I'm going to have that point right there. And then I would check to see what happens when I'm at pi. If I plug in pi here, this gives me -1, so I would have 6 over 1 minus 2, and that gives me -6. Now keep in mind that for -6 pi, that means you're facing over in this direction, but your radius is -6. That means you're going to be coming back to the left 6 units. So 3, 4, 5, and 6. And so what we have here will be our 2 vertices. Now notice that for this vertex, your focus is 2 units to the left. So the other focus would have to be over here 2 units to the right. Hopefully that makes sense. This is going to be our second focus, which means that our transverse axis is, again, what we already said, it's going to be this line right here. And our center is going to have to be the halfway point between these two vertices. So let's get some labels on here. So this is the iliocenter was the rectangular coordinates. That's 2, 0. And this other one was 6, 0. So my center is going to be this point right here. So center is equal to 4, 0. And then we should be able to find out everything else about this, going, referring back to what we've seen with hyperbolas before. All right, so that means that our A value is 2, so the distance from the center to the vertex is 2. My C value is 4. And so from here we can find that B value. So, again, done this plenty of times before, so that means that C squared is A squared plus B squared. So 16 equals 4 plus B squared. B squared is 12, so that means that B equals 2 square roots of 3. Not really the most fun set of points to plot, but we can use that to inform us for the B value going up and down, so we can kind of create our box around here. Let's see, 2 square roots of 3 is about 3.4. So if we were to create our box, we'd go up, something like this, go down about 3.4, and this would be the relative shape for that box. And we could then talk about what our asymptotes would be. Again, not the prettiest, because we're dealing with radicals here, informing us with part of our slope. But we know what the shape is supposed to look like. You draw your nice branches for your hyperbola, and we'll have something like this. Now, if we were to take this and write the rectangular form for this graph, your center is the order pair 4, 0. So that means you would have x minus 4 quantity squared over that A value squared, so it's going to be 2 squared, which is 4, minus, it's just going to be y squared over, and the B value that we found would be underneath the y was 2 square roots of 3, but that came from 12, so we don't need to recreate all of that, and this equals 1. So that will be the equation for this. Now, here's what we're going to do. We're going to actually take this, we're going to take this rectangular, or this polar graph, and we're going to convert it into a rectangular form, okay? So actually, let me just come back up here a second. So that's r equals 6 over 1 plus 2 cosine theta. So we're going to make the conversion, do the same kind of converting tricks that we've done before. First, you want to multiply both sides times the 1 plus 2 cosine theta. So you have r plus 2r cosine theta equals 6. Now, I think the best thing for you to do here is to get the r by itself and then square both sides. And the reason we want to do that is because sometimes things get a little bit messy if we don't. And the pattern, or the steps I'm taking here are going to be the same for all the guys you're going to come across. So we do this, and we square both sides. So we get r squared, which can nicely convert because we know what r squared is equal to. When I square this binomial, I end up with 36 minus, so 6 times 2 is 12, times 2 is 24, r cosine of theta, and then plus 4 r squared cosine squared theta. All right, and now we make our conversions from polar to rectangular. Now r squared, we know, is x squared plus y squared. 36 stays the same. minus 24. Now remember, our cosine theta is just x. And when we have r squared cosine squared, that's x squared. So plus 4x squared. All right, so we're going to have to go through the process of getting things to one side and completing the square. So I'm actually going to move both of these terms to the right side and just kind of rearrange things. So if I subtract the x squared, I end up with 3x squared minus 24x. Whoops. Then we have minus y squared equals, I'm going to take this 36 and move it to the other side and make that a negative 36. So when it comes to completing the square on a problem like this, we first need to factor out the 3. So we have x squared minus 8x, leave some space, and we have the minus y squared. All right. So to complete the square here, we will do half of 8, which is negative 4, and when we square that, we get 16. So even though it looks like I just added 16 on the left, I actually added 16 times 3, so that's 48. So I add 48 on the right. So then minus y squared is equal to positive 12. Divide everything by 12 and reduce. When I do that, I end up with, for this first fraction, x minus 4 squared divided by 4. Then I have y squared over 12 equals 1. And that's the same thing that we came up with from analyzing the graph. That's this equation that I wrote right there. But you know what? Let's go into the graphing calculator and see what we can do there. So for the graphing calculator, we need to make sure that we're in the correct mode. So I need to convert back to polar mode. And now I've got r equals, so I have 6 divided by the quantity, 1 plus 2 cosine theta. Let's check our window to make sure that we've got a good looking window. 0 to 2 pi looks fine. Yeah, let's see what we have. Okay, now, you gotta be very careful because it is giving us these asymptotes. But those guys really aren't there. It's not part of the graph. Those are dashed lines that you see. But with the graphing calculator, if you go to your window, actually go to your table setup. Nope. I think I was trying to go to window. Sorry, format. So used to using another kind of calculator. So if we go down to, maybe it's not here. No, I don't want to change the background. Okay, here it is. So go from, where is it? Well, that's just silly. All right, so I'm going to come over here. I'm going to change this to be I think if I do that, that's going to be okay. Let's see if that changes my graph. All right, so when you do this dot mode as opposed to the connected mode, then you're going to see that you don't have those asymptotes show up. Now, we can make this look a little bit nicer by changing our window and changing the step. And let's just say 2 pi divided by, let's do 360 steps and see what we have there. Yeah, so that gives us a bunch of dots, but it's not going to try to connect the dots to give us a smooth shape, which is what typically the graphing thing does. but you see that the picture that I have right here is the same as the picture that I have over here. All right, so let's take a break and let's try another one here and see if we can come up with similar results.